Hello dear students, let me begin the next lecture. After learning the definition of the line integrals of scalar fields and vector fields, now in this lecture we will solve two examples of calculating the line integrals of the scalar fields. In the first example, we will calculate the line integral of a scalar field f over a curve C, where the scalar field f of x and y and z is given by x plus 2y, and the curve C is a straight line y equal to 2x starting from the origin and ending at the point 1, 2. And in the next example, we have to evaluate the line integral of the scalar field x, y, z over the curve C, which is the helix parametrically described by the equation r of t equal to cos t I unit vector plus sin t j unit vector plus t times k unit vector, where t ranges from 0 to 2 pi. These two examples are very easy to solve. So let me begin to solve these examples. For the first example, first I will take the variable x as the parameter. So it means that x in terms of t, or x as a function of t, is just equal to t. Okay, and from the equation of the curve C, which is the straight line y equal to 2x, it follows that y of t is equal to 2 times x of t. Okay, and since x of t is equal to t, so therefore y in terms of t is just equal to 2 times t. Very simple. So therefore the parametric representation of the given curve C is r of t equal to x of t I unit vector plus y of t j unit vector, and in place of x of t we will put just t, and in place of y of t we will put 2 times t, so that the parametric representation of C becomes r of t equal to t I unit vector plus 2 times t j unit vector. Now we have to find the range of t. Okay, and for this note that we have set x is equal to t, so it means that the variation of x in the given curve gives the variation of the parameter t. And note that the given curve is straight line which starts from origin and it ends at the point 1, 2. So it means that since the value of x at the origin is 0 and the value of x at this point 1, 2 is x equal to 1, so it means that x ranges from 0 to 1 in this straight line. Okay, so therefore the range of t is also the same as the range of x, since x ranges in this line segment from 0 to 1, so therefore t ranges from 0 to 1. Okay, so this is the complete parametric representation of the given line segment. Hopefully this is now clear to you. Now we require r prime of t, which is the derivative of r with respect to t, and this is simply equal to I unit vector because the derivative of t with respect to t is 1, and the derivative of 2t is just equal to 2, so therefore r prime of t is equal to I unit vector plus 2 times j unit vector. Further, we need the magnitude of this r prime of t, and this magnitude is just equal to the magnitude of I unit vector plus 2 times j unit vector. And now we will use the definition of the magnitude. We know that if the given vector is a I unit vector plus b j unit vector plus c k unit vector, then in this case the magnitude of this vector is equal to the square root of the sum of the square of the components, that is a square plus b square plus c square. Very simple. So by using this definition we get this magnitude equal to the square root of 1 square plus 2 square. Very simple, which is equal to the square root of 5. So this is the magnitude of r prime of t. Okay, now we will use the definition of the line integral of the scalar field over the given curve. And for this we know that first we have to express the function f of x and y in terms of t, and for this we have to represent x in terms of t and y in terms of t to get the representation of f in terms of the parametric representation of the curve. Okay, and this thing can also be simply written as f of r of t. Okay, so f of x of t and y of t is obtained by putting the expression of x of t in the given function and the expression of y of t in the given function. And since the given function is f of x and y equal to x plus 2 times y, so therefore f of x of t and y of t is just equal to x of t plus 2 times y of t. Very simple. Now put the value of x of t, that is equal to t, plus 2 times the value of y of t, which is 2 times t. Okay, so it means that t plus 4t, which is further equal to 5t. So it means that f of x of t and y of t is just equal to 5 times t, and we will put this at this position. Okay, and then we will put the value of the magnitude of r prime of t, which is equal to square root 5. Furthermore, the variation of t is from 0 to 1. Okay, so therefore this line integral is equal to this definite integral. Okay, now we will solve this very simple definite integral. We will just substitute the value of f in terms of t and the value of the magnitude of r prime of t. So by doing this, we get this, which simplifies to this. Okay, square root 5 is constant, so therefore it has been taken outside the integral. Now we will perform the integration and we will apply the power rule of integration, so that we get this result, square root 5 times t square by 2, and the limit of integration from 0 to 1. No need to apply the lower limit of integration, as it makes this expression equal to 0. So just apply the upper limit of integration, we get this result, 5 square root 5 divided with 2. So this is the answer. Okay, so it means that in order to solve the line integrals, we should have a good knowledge of solving the definite integral. Okay, now we will solve the next example, the example number 2, in which we have to evaluate the line integral of xyz over the helix, which is r of t equal to cos t I unit vector plus sin t j unit vector plus t k unit vector, where t ranges from 0 to 2 pi. Now we are already given the parametric representation of the given curve. So it means that the line integral is just equal to this. All the first we have to write this function, which is f of x and y and z. We have to write it in terms of t. So for this, x will be written as x of t and y as y of t, and z also in terms of t. And since f of x and y and z is just equal to x, y, z, so it means that this f in terms of t is just equal to x of t multiplied with y of t multiplied with z of t. Okay, and from the parametric representation, it is clear that x of t is cos t and y of t is sin t and z of t is just t. Furthermore, the parameter t ranges from 0 to 2 pi, so it means that the lower limit of integration with respect to t is 0 and the upper limit of integration is 2 pi. Now we will put the value of x of t, y of t and z of t. X of t is just cos t and y of t is sin t and z of t is t. So put these values, and furthermore we need the magnitude of r prime of t, and for this we will take the derivative of r with respect to t. The derivative of cos t is minus sin t, so therefore r prime of t is equal to minus sin t I unit vector, and the derivative of sin t with respect to t is cos t. So therefore we have plus cos t j unit vector, and the derivative of t with respect to t is just 1. So we have next k unit vector. Okay, so therefore the next step is this one, and now we will apply the definition of the magnitude on this vector, so that we have next step, which is this one. Okay, the magnitude of this vector is square root of sine square t plus cos square t plus 1 square. Sine square t plus cos square t is 1, so 1 plus 1 is 2, and the result is the square root 2. Okay, and since square root 2 is constant, it will be taken outside the integral, so that we have this. Now the integrand is 3 times sine 2t, so therefore we need to apply the integration by parts. Okay, that we will do in the next step. So the given line integral is just equal to this. Now apply the integration by parts on the right hand side. Consider the integral on the right hand side and then apply the integration by parts. You have this result. Now we will apply the limits of integration to the first term on the right hand side. We don't need to apply the lower limit of integration, as it makes the numerator equal to 0. So just apply the upper limit of integration, and the result is minus 2 pi. Just we have to put the upper limit of integration against t. So minus 2 pi multiplied with cos 4 pi is the result, and cos 4 pi is just equal to 1. So we have just minus 2 pi on the numerator, and the denominator is 2. So the result is minus 2 pi divided with 2, and the integral on the second term can be simplified to this. Just take 2 outside the integral, and minus can also be taken outside the integral to make the outer minus equal to plus. So we have this result. Now we will take the integral of cos 2t with respect to t, which is just sine 2t divided with 2. Okay, and the result is this one. Apply the upper and lower limit of integration. Both of the limits make sine 2t equal to 0, because sine 4 pi, which is the result of the upper limit of integration, is equal to 0, and sine 0 is also 0. So the result is minus pi. Now we will put the value of this integral at this position. Okay, so that the final result is square root 2 divided with 2 multiplied with minus pi. Okay, and this will be our answer. So hopefully you have understood this and learned from this lecture. This completes our today's discussion. Thanks for watching.